Alright everyone, so in this example, we want to find the recoil velocity of a 3.95 kilogram rifle that fires a 4.5 gram bullet at 310 meters per second. And then we want to know what are the final kinetic energies of the bullet and the rifle. So here, in this system, before anything happens, the bullet and the gun are at rest, and so there's no momentum. After the gun fires the bullet will move forward with some momentum, so the rifle will recoil with the same amount of momentum. And since we know the mass, we can determine the velocity. And then from the velocities, we can determine the final kinetic energies. So remember, the momentum of this closed system is conserved. So the initial momentum must be equal to the final momentum. So if there's no momentum before, that must be equal to the momentums after. And since we know the mass of the gun and the velocity of the gun is what we're looking for, we know the mass of the bullet and the velocity of the bullet, we can determine the recoil velocity of the gun. And you find the recoil velocity to be negative 0.353 meters per second. So now we can just determine the kinetic energy of each, knowing the mass and the velocity of each one. And so we find the kinetic energy of the gun is 0.246 joules, and the kinetic energy of the bullet is 216.225 joules. So remember that towards the end of the chapter we talked about how the change in momentum is equal to a force that you apply times some amount of time. And the change in momentum is just what we called impulse. So when you have a change in momentum through something like firing a gun, but more importantly something like the bullet hitting a target, that change in momentum supplies a force over some amount of time. Similarly, you can see that these objects have some amount of energy associated with them. The energy associated with the rifle and the energy associated with the bullet. Remember that this is kinetic energy, and if you transfer kinetic energy, you can do work. A change in kinetic energy can do work. So even though their momenta are the same, just in opposite directions, the rifle has much less kinetic energy and therefore can do less work than the bullet.